Hello. Today I'm going to try to explain the solution to LeetCode 103 binary tree zigzag order traverse. Okay, so the way this works is we are given some kind of a tree and we have to get the trees. So the previous problem 102 gets it in order. So you go level by level. Okay, this is the problem 102. This is the binary tree level order traversal. So I think we should start there. Okay, then we should think about the zigzag version, the 103. Okay, so the way I solved that problem was let's see, what colors do I have? Blue. So the way I solved that is I had two queues. Okay, this is a queue. This queue is called current level, and this is a queue called next level. So I start with the root in the current level, okay? And then I have a while loop, and I come here and I ask, what are the children in this queue, to the first element of this queue, right? So it's only a root, so its elements are that one and that one. We add that to the next level queue, and we remove this, okay? Whoops. Now I'm done with this level. Now my pointer for the current level, we put it to the next level, and the next level we assign a new queue to it. The garbage collector garbage collects this, and what's this? Is this the last crop? Yeah. Okay. Now we are here. Okay. Okay. Now we change our pointers. We are here. So this is that one. Now, again, we enter the left child first. So this is the left child, and then the right child. This is the right child. So we add, so once we go through the elements, we add the left child first to the end of the queue. So this is the end of the queue, okay? This is the end of the queue. This is the beginning of the queue. So we add from this direction and we remove from that direction, okay? Okay. Now we are back in the loop. So we are asking, what's the first element? Get that. So we are going to get that left element. And the left element has two children. We are going to add the left child first. So we add the left child of the left element. So this is the, I'm going to call it LL, okay? Because that's the left child of the left element. And I'll add the right child of this element. So left child, right child. Oh, and by the way, after we are done with this, we add that to our level order list. So this is the root. Okay, so this is the root. I'm going to call it root. Okay. Now this is the left child of the root. We added its children and we remove it from the queue. So, and then we are going to add it, left child of the root. Okay. And then we come back into the queue and we say, okay, what's the next element? So it's the right child of the root. Okay. So we are gonna look at the right child of the root and ask, what are your children? Here's the left child, there's the right child. So we are gonna add the left child first. So this is the right child, left child, and this is the right child, right? So we added its children, we remove it from the queue and add it to our list, right? So this is the level order. So we were done with the first level. Now we are done with the second level, right? Root, left child, right child. Now, again, notice because we are adding left to right, the children to, we are going to retrieve the children from left to right order over here because we are adding them as we go, and it's first in, first out. So this was first in, this will be first out, that was last in, that would be last out, right? Okay, so we check our current level. Oh, it's empty now. Everything's removed. Okay, so let me change my pointers so that so this is my current level now, and for the next level, I make a new list and assign it. Okay, I mean a new queue. Okay, we are using the linked list as a queue here. Now we are over here. We're gonna ask, what are your children? Because I have no children, so we do not add anything. So nothing here. No, none of these have any children, so we're actually not gonna add anything. So we're gonna ask. Still, we're gonna go through the process. Ask him, what's your left child? Nothing. Actually, I want to add a right child here. Okay, we are gonna call it X. Just to show you how the process works. So I'm gonna ask the LL, what's your left child? Nothing. We're not gonna add anything to here. It's no, we are not doing anything. It's blank. I'm not very familiar with this eraser. Anyways, and for the right child, nothing. So we are done processing this. We're gonna add that here, LL. And now we come here. We're gonna ask, what's your left child? Nothing. We add nothing. We ask, what's your right child? Oh, it has a right child. It's called X. We add that there. Okay, and we are done with both of his children, so we pop it from the list and add it to our level order. Okay, and then over here I have the next one, RL. I'm calling that. It does not have any children, so nothing get added to the next level. RL comes here. I remove that from there, and the RR, which is this one, it does not have any children either. RR. And so I'm removing that. So again, current level is empty. What do we do when it is empty? We change our pointer. So this goes to our current level. Oops, something went wrong. There. And the next level is a new queue. We just assigned it some memory. Now we are here. We are gonna ask, what's your children? I have no children, so we do not add anything here. We remove it and add it here. So this is our level order. So see how this works? Root, left child of the root, right child. So root, left child of the root, right child, and then left child of the left child, then right child of the left child. Okay, and then left child of the right child, and then right child of the right child. And then in the next level, we have the X. So we have it in level order. Fine. So this is problem 102. Now, problem 103, however, wants to get it in a zigzag order. So I'm going to draw a list again. Let me add a couple children here. Okay. So we go through the first level like this. It wants us to go this way, and then this way, and then this way. Now that's a little more difficult. And instead of this, I'm gonna actually name them R, and I'm gonna go A, B, so that we can call it C, D, E, F, G, H. Notice I name them in a level order fashion, right? But we are gonna go forward and backward depending on what level we're on. Okay, so the correct answer to this would be I go forward on the first level, so R, that's the root. Then instead of A, B like before, we have to go backwards, B, A. Now think about it. What does it mean to go backwards? So if we set it up in a queue, here is A, here is B. When we are processing the root R, we would add A, B. We have to remove them from the other end of the queue in order for us to write BA, right? And while we do that, we have to add the children to the children's queue. And since we are at B, we cannot add anything from there. We have to add from the right child, right? When we're going backwards, we add the right child first. We're going to add F, E, D, C, and then when we are actually on this level, however, we're supposed to go forward. So we added them from the other end, and now we are reading it from this end. So C, D, E. Wait, no, we have to read it from that end. So it's C, D, E, F. C, D, E, F. And then we go backwards again. I'm going to remove these. H, G. So R, B, A, C, D, E, F, H, G. Okay, let's think about it a little more. So I said I needed a double-ended queue. So in Java, there is a class called deck. Sorry, this is an interface, and this is implemented by linked list. So we can use a linked list for this. Okay, so the way this works is hopefully I don't mix up my lefts and rights. So let's go through the tree and write it out. This is our current level. This is our next level. Okay, the current level we start with R. In my program, I always have something in the current level. If the R is null, we just return null. That's just a weird case. But this is the normal case. So we have something in the current level. My program ends when the current level is empty. And at the end of every loop, I assign the current level to the next level. So basically, I'm checking if there are any more children. So you can check that too. Okay, let's go through this. So now we have to think about which way we are coming from. So we added the R from the end of the list. So this is add last, okay? That's how we added the R. This is a forward direction. And then we will remove this with get first. Okay, this method will remove the head of this queue, and this is happens to be just R. In the first level, it doesn't matter as much, but as we go, maybe I'll add a couple more levels. Okay, I'm gonna add G, H, I, J, K, L. So we can think about it a little more. I'm gonna go through all of the steps, and hopefully that will make sense by then. Okay, anyways, so we are at R. Oh, and we have a boolean called forward. It's now set to true, meaning we are going forwards now. So this is how the forward process, okay? So we get the first element, right? And since we're going forward, we add normally from there. So we add things, we build the list from the left side to the right side. In order to do that, we have to add things to the end, right? So let's add the children of the R. We add A with add last. Okay, we added A to the last. When we remove it, we'll remove it from, we have to think about that, but we are adding it to the end now. B, that's the next child. So we are adding the left child first, then the right child. So we are adding B with the same method, add last, okay? So we have A, B, we remove the R, and we put it there. Cool, we are done with that. Now we have to go backwards and all that stuff. Okay, but let me remove this list with the garbage collector because that's empty. And what did I do? I did something. I actually, let me remove this. I just need this list, not how it came to be. Cool, I'm getting more the hang of it. Anyways, so I reassign that. So that's my current level. I assign some new memory to the next level for it to work now. Now the difference is right now the forward boolean would be false because at the end of the forward cycle I would change this. Now this is false. I am going backwards. Now, in order to go backwards, my list is uh, so my list will always be in level order. It will be like A, B. I will remove it from the other end. That's how I implemented it. You can think of it backwards, but I can't think that way. So I'll think of it as removing from this side, okay? So this is remove last. So if we remove the last, we can then add the B there, right? So we have to remove the last. So that will remove, take the B. Now, we want to build the children in the next level. So think about it. When we were going forward, we added the left child first. But now, since we're going backwards, we have to start building from here to over there. So we have to add the right child first. We have to add the F first, okay? So we add the F. What method do we use to add that? We add that to the end, okay? So we add last. Actually, we have to build this way. So I'm gonna add to the first, okay? This is not the right way to do it. I'm calling this, I'm adding it from this side instead, because I'm gonna add the E from this side to over here so that the Q's are level order, okay? So this is actually add first. Okay, I added the F. What's the big deal? So I added the right child first, so that's done. And now I will add the left child afterwards. Again, with the add first will add it from this side, okay, from the first side of the queue. And, okay, good. So I have added E. So I am done processing B because I have added the right child of the B, then the left child of the B. Now we print it. Okay, or we add it to our level order list. If you're making a list, cool. We're done with this. Okay, let's continue. We are going backwards. We're just done with this. What do we do when we go backwards? We take the end of the list. We again use the remove last function. That happens to be A. Okay, we are at A. For A, we have to add its children. Again, the right child first. So let's add D. Now, which function are we going to use? We are going to use add first. We're going to add the D to the beginning of the list. Okay. And then we are going to add the left child. We're going to add C to the beginning of the list. Now we're done with A. We put A on our list, our results. So we are done with the first two levels. The second level was backwards. And at the end of this loop, I'm going to change this. So, okay, now you go forward again. Notice in this implementation, the queues will always have the elements in the level order, in the order they are in the level. That makes sense to me. I think of it as taking it from the left side, thinking it of from the right side, okay? Okay, now let me remove all of this again and exchange some pointers. Here is our current level. And here is some new memory for the next level. Okay, now, are we going forwards or backwards? We are going forward. So we take from this side. What's this side? This is the beginning side, okay? This is the first element. This is the last element. Okay, let's use this method. Remove first. Okay, we have the C in our hand. Now, what's the technique when we are going forwards? We add the left child first, okay? Suppose there was a child called X over here. Suppose, okay? We are going to use that in our example just to show. Now we are going forwards like this. The Boolean forwards is true. We have to add the left child first so that we have the next level as level, like how it appears in the tree in the level order. So the left child is X. We add the X. Okay. Right child is G. We add the G. We are done with the C. Okay, what do we do now? We are done with this. We add the C there. Cool, we are in business. Okay, now, what's the first element? Again, we are coming from the left to right. That's why we're doing the first element first, right? Now we ask D, do you have any children? This is no, I have no children. Okay. We will put you on the results, and you have no children, so nothing gets added. E, do you have any children? E says, I have H as my child. Now, okay, I forgot to tell you what function we are adding. We are building this list from the left to the right, okay? When we're building this list, starting at the left and adding things to the right, so we are adding things to the right, okay? So the function is add last. The last is the right-hand side. The first is the left-hand side, okay? Okay, so we add H using the add last function. Okay, and does E have any right children? No. Okay, so we are done with E. We add them to our final answer, and then we are back again. Are we going forward? Yes, we're going forward. Let's work with F. Okay, F, do you have any children? F does not have any children. Remove the F. Add it to our answer. Okay. Okay, and now we are done with the current level. Current level is empty. I am gonna flip the boolean. Okay, so garbage collector collects that. I'm gonna reassign this memory to that. Okay, that's my current level now. Okay, next level is some new memory. Okay, now are we going forward? No, we are going backwards. Okay, how do we go backwards? In order to go backwards, we have to pop from the end of the queue. So remove last. Whoops, that's not the right way to write it. Remove last. If you remove last, we would get the H because we want to go from this way to that way. Okay, so we are working with the H now. Okay, now remember, we want to build this list out so that it looks like this I, J, K, L over here, right? So we are working with H now. So we have access to both K and L, but we have to add the L first. So when we're going backwards, the right child gets added first, and it gets added from this direction, okay? Because we will be building this out from this way to that way. So the first element is the L, okay? But I'm gonna add it like this from this side, okay? L. So this is the add first. Add first method adds the right child of the H. Okay, this is added. And then the left child of the H is K. I have added the K. Cool, that's how we are adding. I'm just going to remove that. We are done with the H. What do I do with the H? I put it in my list. Okay, fine. That's H done. Again, I ask the list, what's your last element? Remove last again. Okay, with that remove last, I have access to the G. Now I ask the G, what's your right child? Remember, we're going backwards, right child comes first. We add that to the beginning of our double-ended queue, right? So this is J comes here. We use the add first method. Remember, we're building from left to right, so we are adding things to the left. Yeah. And then the left child of the G is I. We add that. Cool. We are done with the G. There is the G. And then we ask X. X, what's your right child? What's your left child? X is I have no children. We remove the X and put it here. Okay. And let's just write this down, X, and then the next level will come forward, I, J, K, L. Okay. We're gonna verify that. So we added the X. Okay, cool. Now this gets garbage collected by the garbage collector. We reassign this memory to the current level pointer. We assign some new memory to the new level. Fine. Now, and by the way, at the end of that, I have to flip this boolean. Now we are again going forward. Okay, so we are done with this level. Okay, we are going forward now. Forward means which way do I go? I go from this way to that way. So I remove that. Okay, so this is remove. What do you remove? The first? Yes, the first. If I was going backwards, I was remove that, but I'm not going backwards. Okay, so we're removing the first. So we have access to the I. Okay. Now we asked, none of these have any children, so the next level will be empty. So we asked, I, do you have any children? I said, I have no children. Okay, so I'm gonna add you to our answer. We come to the J. J, do you have any children? No, I don't have any children, so nothing gets added there. So we add the J over there. K, no children, add him. L, no children, add her. Cool. So we are done with this, and the way I programmed it, at the end of the loop, I reassign everything like this, and then I ask, is this empty? If this is empty, it means that's I'm done. No current level. So as you can see, this worked. Okay, so that's the end of my explanation. I'm just gonna run through the code now. Okay, hope this works. Okay, here we are. Where are we? Okay, I found it. I just wanted to show you that this submission is runtime 0 seconds, and it bits 100% of the things. Where is it? There I am. It bits everything. That's cool. But this is not that important. Sometimes it varies. Okay, I lost track of this. Let me pause and come back. Okay, I found my code. So this is how my function works. So this, excuse me, let me put this away. So this is the zigzag level order. I am supposed to return a list of integers. Each list is a level, okay? So I declare a list of integer with a linked list. And then if the root is null, I return this empty list called zigzag. Okay, that's the weird case. Now I am making this deck class with 3 node objects inside, and I'm calling this level the parent level, and then a child level. You can also call it current level, next level. Okay, I like to think of them as parent and children. That makes the thoughts easier. In the parent level, I add the root. Now the fun begins. We start with a Boolean forward. Um, to be true. So that means we are going forwards. Now, my while loop condition is I'm checking if the parent level is empty. Because at the end of the whole thing, I assign the parent level to the child level and add the assign some new memory to the child level. Okay, so parent level means actually current level. I'm just checking is current level empty. So if it's not empty, I continue with new levels. Okay. This is a list of integers. So this is the values of the current level. I'm going to add them there. Now this is if we are going forward, we do this. If we are going backwards, we do this. Okay, let's think about it. So again, we are gonna go through the condition is very similar. This condition, I think you can think of it as if child level is empty, but I don't know how to do that. That's not intuitive. I'm happy with this, so I'm going to continue with this. Again, I'm going through this level and I'm checking if this level is empty. Okay. I think I cut off. So what am I doing over here? I am going from the left to right, okay? Because this is forward. So if we go left to right, think about it. What child do you want to add to your child level? So you want to add your left child first, then the right child, and also put your own value to our list. Okay, level vals, that's this. We are adding the current node's value dot val, and we are calling the. So, oh, I forgot to tell you about this. This is very important. So when we are going forward, we have to remove from the left side of the double-ended queue. So we have to use the remove first method. And the children get added to the end of the queue because remember, we are building from the left to the right. We are going from the left to the right in the parent queue, we must build our child queue from left to right, okay? And to build from the left to right, we have to add things to the right, okay? So that's what we're doing at last, okay? So that's the forward direction. Now, at the end of the forward phase, we set the forward boolean to false. It means now it's backwards phase. We have an else condition, so that we are here if this is the backward phase. Again, we go through until the parent list is empty. Now, what does it mean to go backwards? We have to pop things from the other end. That's what it is. Parent is parent level dot remove last. So we are removing the last element. Now, once we remove the last element, we want to build the children level. We have to add the children from right to left, and we have to add the right child first. So that's what we're doing. If the right is not a null, if it's an actual child, we add the right child to the first of the list. Why? Because we are building from the left to the right. So the new elements get added to the right, okay? So we are adding the right child first, then the left child, excuse me, and then we add my current value to our list, and then after the whole uh, thing is done, we set the forward to true. Okay, yeah, we set the forward to true at every node, but it doesn't matter. We are already in this else loop. Maybe there was a better way to do this. I don't know. Anyway, so at the end of this if and else condition, you know what? This doesn't look right. I'm gonna add this afterwards. I don't want to interact with the boolean when I don't have to. Yeah, I'll add this, the forward and backward flipping. I'm gonna add this outside of the while loop. It's weird to do inside the while loop, right? After I'm done with all the elements, then I flip, okay? And now the zigzag, remember this was our all the levels that we return. So after this portion, if and the else, either we go forwards or backwards, we end up with this level vals, right? We add that to our zigzag, and then we reassign the child, whatever children we have collected, we reassign that to the parent pointer. The child pointer gets assigned some new memory. Okay, and then at now here we are done with the outer while loop, so we are done with all our elements. Now we return to zigzag. I just want to submit and run to see if this works. Huh, 1 milliseconds. Cool. So again, it's the same idea. Here, I could have been here. It doesn't matter. That Yeah, that concludes my answer. If you have any questions, please comment. I'm gonna post this to YouTube, and that's it. Thank you for your time. Bye bye.